Hello, I'm Hiro Nanayakara.
And I'm Yahan Bandara. We are Curtin University students studying computer systems and networking in year 3.
So for our project progress, we have already completed project video 1, and this is our project video 2. We have an ongoing Gantt chart, and we have an ongoing research proposal, which we have completed the introduction, main objective, and sub-objectives. So for our main objective, we have to create a real-time asset monitoring system for logistics to monitor package movements and guarantee that packages in a shipment do not go missing throughout the logistic process. The system may give accurate tracking data even in places where standard monitoring methods are ineffective by utilizing RFID, GPS, machine learning, and blockchain technologies. For our sub-objectives, we have implementation of CCTV camera with SIM integration, integration of RFID technology, and cloud connectivity data management. For our research questions, we have RFID technology, potential security vulnerabilities, and integration of GPS technologies. And Jahan will explain more about the system architecture.
Thank you, Mihiro. So the system architecture of our system is that the packages or the products that are needed to be transported from location A to location B is safely transported through the distance, right? So first of all, the packages are loaded onto this container in the lorry. So the container's frame has 3 RFID scanners, which we are implementing so that when a package is inserted onto the container, it is scanned from all 3 dimensions. And the RFID scanners, as you can see, it is integrated with the CCTV. So it is working synchronized as a synchronized function. And the CCTV, it identifies, it's there to identify the person who is currently placing the carton or the box inside the container. So we know who was the last person who interacted with the packages before it gets to the next destination. And the cloud system, as you can see, we are sending all this data to the cloud. So if we are asking how we are going to do this, we're using a 4G SIM integrated onto the CCTV camera. So it has a cellular network, and we're transmitting live stream data to the cloud so the supervisors can review and see the status of the transportation of the valuable goods or the process. All of this is shown in our final step, which is a web application, and then the CCTV and everything on the back end of it and the front end can be accessed and controlled through the web application. So as you can see here, this is the system implementation. And this is, as you can see on the right, there are 2 images. On the top image on the right, what we are trying to show is that this is an example from the Rivian van from Amazon Prime. This is how we are trying to implement the camera module for our containers as well. It's going to be a portable magnetic camera module, which has a 4G SIM included in it with facial recognition, infrared, and night vision as well. This is the outer view of the camera. As you can see, we will be placing another camera out in the outer view of the container as well. So as for the system implementation, after the tag printing process, which is the passive RFID tag, it has a very high frequency and it is very accurate. So those tags are printed and it's applied on the carton box. The carton box is then packaged with the relevant customer requirement, any product, and then the carton box is sent to the warehouse. From the warehouse, it is transported into the lorry, and then as you can see, I mentioned the 3 RFID scanners in the previous slide. So you can see there are 3 blue RFID scanners here, shown in blue, and then there are fixed readers, and there's a RFID antenna for each container as well. So as you place a box inside the lorry container, it automatically sends a signal to our web-based application. So for data storage and security, this is the method we are using. So the smart CCTV, which contains the 4G SIM module, is directly connected to the cloud server, even the RFID scanner and the GPS. So the in and out of the packages, so the serial numbers of the packages that went through into the lorry and was taken out of the lorry are stored through blockchain technology. So basically what we are trying to do is have a decentralized system to store those values of the package in times and the package out times, so that imagine a package was lost, so the supervisors can easily access the database and see where the scenario took place and take legal action for it. So as you can see here, I mentioned earlier as well, this is the technology stack. This was mentioned in the video 1, where we explained briefly about the RFID technology, the GPS system that we are trying to implement onto the lorry, so we can track where it is currently, and then the CCTV and the decentralized system. This is a small overview of the web application. So as you can see here, we can input a packet number and the driver details automatically comes. The literature review. So the literature review consists, these are some of the literature reviews that we have implemented on the project proposal. And then this is the real-time video streaming. Basically, the real-time video streaming comes from an integration of a 4G SIM into the CCTV camera to allow seamless real-time video streaming. And it discusses the benefits of using 4G connectivity for live video transmission, enabling supervisors to monitor the package handling and secure the transportation as mentioned previously. This is the literature review for the RFID technology. The RFID technology has been widely adopted in logistics for package tracking, and the RFID tags for real-time tracking, such as fast read rates, it's very cost effective, and compatibility is in the high ranges for the logistic infrastructure. The blockchain for secure data storage, as I mentioned, we are trying to implement a decentralized system to implement the in and out times of the boxes or the packages inside and outside of the lorry, right? So this is to prevent any data manipulation or unauthorized access of handling of the packages. Moving on to the passive RFID system. There are several types of RFID systems, like passive RFID and active RFID. So what we're trying to use is passive RFID system. So in a passive RFID system, the tags do not use a battery. Instead, they receive their energy to run from the reader, right? So what happens is the reader emits an energy field of a few feet, providing the energy of any tag in the area, right? The tag gathers the electromagnetic energy from the card reader, powers up, and responds with hello world or its identification information. So the active RFID tags are empowered in such a way that they emit every signal every 30 seconds, right? It is highly accurate and it's automated with nearly 100% read rate. So this is very cost effective, as well, as I mentioned in the earlier slide. So one RFID system, one RFID tag costs around $0.10. So then it is very cheap and usable on to our application, which is warehouses. Thank you so much.